right, hello everyone. So we have the following problem here. We're going to evaluate the integral that goes from minus infinity to infinity, tangent inverse 4x divided by 16x squared plus 1 dx. And first thing we're going to do is we're going to split up this integral. Our two limits of integration have an infinity in there. So what you have to do in order for you to evaluate this integral is you got to split it up. And we're going to split that integral up into two, one that goes from minus infinity to 0, and then 0 to infinity. And that's in general how that works with your integral. Now, this can be other number other than 0. It can be 1, it could be 2. Technically, your function, you want it to be continuous at those numbers. But I'm just, with this case, it's not, at 0 it is continuous, so there's nothing wrong with plugging 0 in. But yeah, it could technically be any number as long as the function is continuous. And here's what we need to do. In order for the original integral to converge or diverge or whatever it does, you have to look at both the cases here. If one of these integrals were to, sorry, let me begin with this. If both integrals converge, then the whole integral converges. If one integral converges and the other one diverges, then the whole thing diverges. Okay, so that's what we're going to be working on here. And if they were to both diverge, then that's a whole other story here. So let's see what we have. I'm going to go from there. So I'm going to split this up into two cases. My first case is we're going to look at that integral that goes from minus infinity to 0 of my function. And when you're working with an improper integral, you have to replace the part where the discontinuity occurs, quote unquote, or where you have an infinite limit with a letter. So in this case, the negative infinity I'm going to replace with b. And we're going to say we're going to take the limit as b goes to negative infinity. Integral b to 0, tangent inverse 4x divided by 16x squared plus 1. Okay, and yeah, we're going to go b goes to negative infinity. Now, in order for me to take care of that integration, I'm going to use a u sub. And one thing that I'm very particular about, and this is like a real personal point, I do not, when I do an integration with an improper integral, I do not like working with the limits. So I do like an indefinite integral and then worry about the limits back in at the end. The reason for that is because if I change the limits, if I do a u substitution, I got to change the limits around with the notation, and I just don't like dealing with the notation. So I am just going to do an indefinite integral and then plug in the original limits in, and I did a u sub, and I'll let you look at that, and I recommend maybe you pause this video to see. I'm not going to go through the specifics, but I get tangent inverse of 4x all squared divided by 8 as my integrand. So therefore, this limit of that integral that I was working with originally, right here, now turns into the limit as b goes to negative infinity of tangent inverse 4x all squared divided by 8. We're going from 0 to b. And if you plug 0 in, you get 0, because the tangent inverse of 0 is 0. Now, and then we plug our b in, and what's that limit going to equal? Well, if you take a look at our graph here that I just drew, that's the graph of tangent inverse. And as tangent inverse, as b goes to negative infinity, tangent inverse goes to negative pi over 2. It doesn't matter if it's the 4b inside here. It goes to negative infinity, and therefore it tends towards negative pi over 2. So you would have negative pi over 2 squared over 8, and that gives you a pi squared over 32, but because of the negative here, becomes a negative pi squared over 32, okay? And that's the first case, so it converged. So therefore, I need to see what the second case is. If the first case had diverged, if we had gotten an infinity, then we would be done. We'd say it diverges here. Now for case 2, we're going to go ahead and integrate from 0 to infinity now. And similarly here, you're going to get pi squared over 32, so it converges. And therefore, your final answer, you would say that both you're going to add both your answers, and the answer total would be that this integral converges to 0. Yeah, if case 2 had given me a divergence, then I would have said this whole thing diverges, because one part diverges, the other converges. And our final answer was equal to 0, as I said, because of those two parts adding up. So converges to 0 is also something we would write down. And yes, and I hope this helps. Thank you for your time.